Hello class, this is lesson 7 on composite figures. And your objective is, I can find the area of composite figures by breaking them apart. Let's jump into our vocab word, which is a composite figure. So a composite figure is figures made up of two or more simpler figures, such as triangles and quadrilaterals. So remember, we have our obtuse triangles, our acute triangles, and our right triangles. And then a quadrilateral is anything with four sides. So we have square, rectangle, parallelogram, and even a trapezoid would be considered a quadrilateral. All right, so here we have this shape, and this is a composite figure. So this whole thing is a composite figure. But within this composite figure, I have other figures. So for example, here I have two triangles. And then I have three quadrilaterals. So what do you think we would need to do in order to find the area of this entire composite figure? If it's broken up into smaller figures, well, not broken up, it's made up of smaller figures. So to find the area of composite figures, you need to find the area of all the smaller figures inside and then add it all up. So we're not going to have one formula to find the area for a composite figure. It's going to be a combination of many. So let's write what we know. So we know parallelogram, the area equals base times height. That is our basic shape. Then from a parallelogram, we go into a triangle, which is area equals 1/2 base times height. Then we go into a trapezoid, which is area equals 1/2 base 1 plus base 2 times height. And then we have a polygon, which I highly doubt you will have a polygon in a composite figure, but it's good to know just in case, right? So we will be using these areas to find the area of a composite figure. Let's jump into unlock the problem. So here I have a composite figure and I need to find the area. I'm going to start by identifying these shapes. So I have triangle here and here. I have two rectangles or parallelograms, right? A rectangle is a parallelogram. And then I have a square here. So I'm going to break this up. I'm going to do the triangle first, just because why not? So the area equals 1/2 base times height. And our height is right here. It's telling us our height here. And our base, they're telling the base down here. Because see, this 4 feet is the same down here as it is up here. So it would be 4 feet here also, and right here also. So the area for the triangle is a half, base, which is 4, height, which is also 4. Now I'm going to solve as normal. So the area for one of the triangles is 8 feet squared. But I have 2 triangles. So if I'm finding the area for this whole shape, I need to multiply my answer, my area, by the number of shapes I have. So I have the area times the number of shapes. So then I would have 8 times 2, which gives me 16 feet squared. So that's for my triangles. Now I can do my parallelograms. Which is area equals base times height. I'm going to plug in what I'm given. So the base is 4 and the height is right here. See the orange line? So it's 10 feet. So I'm going to plug in 10 into my height. So the area equals 40 feet squared. Now that is for one parallelogram, and I have 2 parallelograms. So I need to multiply 40 by the number of shapes. So the number of shapes is 2. When I do that, I get 80 feet squared. So that's the area for all the parallelograms in my composite figure. Now let's move on to our final shape, which is a square. And for a square, the area equals side squared, which is just s squared. So if I plug in what I have, it would be a equals 4 times 4, because all the sides are the same. So that's the same as 4 squared, right? So when I multiply 4 times 4, I get 16. So the area for the square equals 16 feet squared. But I need to look back at my composite figure here, because when I found the area for my parallelogram and triangle, remember I only found it for one of those shapes. So 40 was the shape area for just that one, and then 80 was the shape area for the 1 and 2, and then 16 was the area for the triangles. There's no other square in this, so I don't need to multiply anything. So I can go straight to combining my areas. So I'm going to add 16 plus 80 plus 16 because I need to combine all the areas I found, because I need to find the area for this entire shape. So 16 plus 16 is 32, and I can add 80 to that, which would give me 112. So the area equals 112 feet squared. All right, let's jump into our steps. Step 1 is to identify the shapes within your composite figure, or the bigger shape. So in this example, I have 2 parallelograms, 2 triangles, and 1 square. Next, I need to find the area of each shape. So I'll start with, and I chose the parallelograms first, so I'm going to label it. So now I'm finding the area for my parallelograms. You're going to want to break up your work. So I'm finding the area for the parallelograms now, and I'm going to use the formula base times height. So now I just need to solve as I usually would. So remember, if you are finding parallelograms and you don't remember how to, go back to 10.1. And I'm plugging in my 4 for my base, 10 for my height. When I multiply that, I get 40. So my area for the parallelogram is 40 feet squared. And that is for one parallelogram. Next, I'm going to move on and find the area for my triangle. So remember, I'm breaking this up. And the area of a triangle is half of a parallelogram. So the area is a half base times height. So I'm going to plug in what I'm given. So I don't have the area, but I have half. Base is is 4 times 4 in this case. And I'm going to remember, when I need to find the area for a triangle, look back at 10.2 and 10.3 for help. So I multiply 4 times 4, so I bring my half down. 4 times 4 is 16, so now I have 16 times a half, which multiplying by the half is the same as dividing by 2, so the area is 8 feet squared. And that's for one triangle. Now I need to move on and find the area for my square. I went over how to find the area of a square in 10.1. So if you want to see an example of that, look back at 10.1. And remember, the area is just side squared because all the sides are the same length. So the area equals 4 squared. So I have 4 times 4, which is 16. And that's 16 feet squared, and that's for one square. Now I need to multiply the area for each shape by the number of that specific shape. So I have the area of one parallelogram is 40, and I have 2 parallelograms in this problem. So I would multiply 40 by 2, which would give me 80 feet squared. Next, that is for my parallelograms. And now I need to do the same thing for my triangles. So the area I found for the one triangle was 8 feet squared. And I have 2 triangles in this problem. So I would have to take 8 and multiply by 2 and get 16 feet squared. So that is the area for both triangles. Now I'm going to find the area for the square. So the area for one square was 16 feet. And I had only one square in the problem. So do I need to multiply 16 by anything? Well, I can multiply it by 1, but that's going to give me the same thing, right? So I don't really need to multiply it in that case if there's only one shape. So all of this are the individual shapes areas. But I don't want to know the area of all the individual shapes. I want to know the area of the whole composite figure. So I need to do step 4 in order to have the entire composite figure. So step 4 is find the total area of the composite shape. So just by looking at the word total, you should know what operation we will be doing. So total tells us we will be adding, right? So we find the total area of the composite shape by adding the area of each individual shape. So we have 80 plus 16 plus 16. The 16 plus 16 is 32. Bring my 80 over, add that all together, and I get 112. So the area for the whole composite figure is 112 feet squared. So there's lots of steps and lots of places to make silly mistakes, but it's not hard if you just go step by step and work slowly. All right, here's my first example. So I need to find the area of the entire composite figure. So I'm going to start by identifying my shapes. I have one square. I know it's a square because all the sides are equal. Then I have one trapezoid, and I know it's a trapezoid, not a parallelogram, because the bases here, there's only two bases that are parallel. So the bottom base here and the top base are parallel. They'll never touch each other. Whereas a parallelogram, all the sides are parallel. Next I have a triangle. So let's write one trapezoid, forgot to write that, and one triangle. And it's one right triangle. Now I'm going to start by solving and find the area for each one. So I'm going to start with the square. My formula is s squared, so side squared. So my side length is 3, so I plug in what I know. The area is 3 squared. Area equals 9 centimeters squared. Next I have my trapezoid. So I'm going to start by breaking it apart. And my area to find a trapezoid is 1/2 base 1 plus base 2 times h. And I remember you can go back to 10.4/10.5 if you need more review with that. So I plug in what I'm given. Base 1 is 3 centimeters, because see up here it's 3 centimeters, so since this is square, the 3 centimeters is also at the bottom there, so it is 3 plus 5, and we're multiplying that by our height, which we can see here on our trapezoid. It is this line here, so it is 5. Now I'm going to solve, so I have 3 plus 5, which gives me 8 times 5. And multiplying by 1/2 is the same as dividing by 2. So I have 4 times 5, and 4 times 5 equals 20. So the area of this trapezoid is 20 centimeters squared. Now I need to solve for my triangle. Alright, so the the formula for a triangle is 1/2 base times height. Plug in what I know, so I have 1/2. My base is this bottom 2, see they tell me this is 2. And my height, oh look, I have this part of the height, but that's not how tall my triangle is. My triangle goes all the way up. So see, this is 5 centimeters. That's only that fraction of my height. What about this top part? How high is that top part? 3 centimeters. So I need to add those together to get my height. So I have 3 here, 5 here. So the whole height of my triangle is 8. So I put that here. And now I solve. So 2 times 8 is 16. A equals 8 centimeters squared. Now that I have found the area for each individual shape, I need to find the area for the whole composite figure. Usually I would now multiply the areas I found for each individual shape by the number of shapes themselves, but there's only one of each shape. So there's only one trapezoid, one triangle, and one square. So now to combine the composite figure's area, I don't need to multiply them by anything. I just need to add the areas I have. So I'm moving to step 4 and adding all the areas that I found. And when I do that, I have 9 plus 8, which gives me 17. And I'll rewrite my problem over here. So I have 20 plus 17, and I got the 17 from adding 9 and 8 and brought my 20 over. So now I have 37 centimeters squared. So my area equals 37 centimeters squared. That's for the entire composite figure made up of all of those individual shapes. All right, here's example 2. So I need to find the area of this composite figure. So I need to start by identifying these shapes. So I have one trapezoid, one square, and one triangle. Now I'm going to solve this. First, I'll solve for my trapezoid, which the area equals half base 1 plus base 2 times the height. And I'm going to plug in what I have. My base 1 is here. So see, the base down here is 12. Since this is a square, the base up here is also 12, because all those sides are 12. So my base 1 is 12. Base 2 is there at the top, so it's 9. Oops, I forgot my h. My height is 6. Now I solve as normal. So I have area equals a half and times 12 plus 9, which gives us 21, times our height, which is 6. And when I multiply that, I get area equals a half times 21 times 6. So 6 times 1 is 6, and 6 times 2 is 12. So we have 126 times a half, which is the same as dividing by 2. So 2 can go into 12 6 times, and it can go into 6 3 times. So our area equals 63 centimeters squared. That's just for our trapezoid. Now we need to move on and find our area for our triangle. So let's do that. So our formula here is area equals a half base times height. And I'm starting with the half. My base for my triangle is 16. And the height for my triangle is 12. Because look, it is a side that is part of my square. So all the sides of this square are 12. So the height of my triangle is 12. Don't let them mess you up with the 20 on the long angled line. The side length is the height, which is 12. So let's do that. So I have area equals a half times 16, which is the same as dividing by 2. So 16 divided by 2 is 8 times 12. Area equals 8 times 12. And when you multiply that, you get 96 centimeters squared. And that is the area for my triangle. Now I need to find the area for my square. So the formula is A equals side squared. So my side length is 12, so it is 12 squared. So area equals 12 times 12, which is 144 centimeters squared. Now I'd move on to step 3, which is to multiply by the number of shapes. But I only have one shape each. So usually I would multiply the area I found for one shape by the number of shapes there are, but I don't have that here. I only have one shape of each, so I can move on to find the composite figure's area. So I'm skipping step 3 and going straight to step 4. So I'm going to add all my areas, which is 63, 96, and 144. Now when I add this, I have 4 plus 6 is 10, plus 3 is 13, carry my 1. 9 plus 1 is 10, plus 4 is 14, plus 6 is 20. So I have 0 and carry my 2. Now I have 1 plus 2 is 3. So the area for my entire composite figure area equals 303 centimeters squared. And that is my final answer. Alright, that is it for today. I will see you guys at your designated meeting time. Bye guys.